Hello. You hear me correctly in the back? Yes? Okay. So the first point is that there's no XML in this talk, so sorry, Mario. It's only server-side browsing. So you give an URL to a third-party server, and it tries to reach it. That's the only point of this talk. So I will give you some context. What did I try and where? Vectors, which are features we can use or abuse to browse URLs. Targets, which are destinations we want to reach. Blacklist, because it's the most common protection measure you will meet. Bugs, which are real-life vulnerabilities coming from bug bounties. And then a quick overview of the toolbox. So first, some context. The methodology is very basic, very simple, and very dumb. It's only looking for server-side features allowing to browse, taking URL as an input. And in a perfect world, we want to have responses echoed back to ourselves. So you can reach something and have the feedback. If you don't have the feedback, it's still cool. We will identify protections, and most of the time we will be able to bypass them. It's not so hard. And of course, during this, once we have our vector and our target, we have to exploit something, and we will try to maximize impact because it's more money for bug bounties. And I prefer to report remote code execution or the compromise of a whole cloud setup than just a simple outbound port scan. So we will look for remote code execution and stuff like that. This is creatively express my laziness. So this is taking. It's taking only a small amount of my time. So it's not my professional work that I present right now. Scope. So I covered only a few bug bounty programs: Facebook, Yahoo, Coinbase, PayPal, and more. So if this evening you do not plan to go to the OWASP party, probably you can score on some others bug bounty programs. So decide. And I have some very subjective criteria regarding my targets. Is the domain name sexy, like facebook.com is cool? Do we have a good security team in front of us? Do they react fast, and do they pay well? So if everything is fine, I will work with them, of course. Vectors. So vectors are features that we are looking for in our target applications. Okay, so this is very, very common. This is resources for developers. Plenty of websites allow you to, as a developer, to register to a specific website and do specific stuff. For example, Adobe provides an API Explorer, and you can decide which endpoint you want to reach. So this is a perfect vector. Now it's whitelisted, so it's not exploitable anymore, in my opinion. In the payment world, everything from real money to Bitcoin. No, absolutely not. Okay. So, excuse me. In the payment world, you have IPN, which are instant payment notifications, also known as webhooks, also known as callbacks. And it's if something happens on the website, then you are notified. So if you receive some Bitcoin on your wallet, then you are notified by a GET or POST request. So this is IPN. And as a developer, you can debug your IPN request, so you can see what is happening on the network. This is cool. You have everything related to third-party data sources. Upload from URL is common on Dropbox, Fastmail, and nearly everybody allow to import RSS feeds. And of course, if you import RSS feeds, you are reaching an external URL and retrieving an XML document and parsing it and everything. So you have a very big attack surface, but XML is not the topic today. Sorry, Mario. Then we have third-party authentication. that's used a lot, and most of the time it's considered as a black box for developers. So they have absolutely no idea of what is the workflow of OAuth 2, for example. Western Union is running SAML, and they have a bug bounty. So if you are an expert in SAML, you should have a look. I know we have a few of them here. More vectors or more features. You have everything which is related to the core business features. So Google Translate can translate a remote document, which is reaching a URL, downloading the document, and processing it. If you use Prezi, you can export your content to a portable format, which is a zip archive. And every external resource included in your presentation will be fetched by Prezi servers and stored in the archive. So this is very atypical but cool vector. This is nice. Mixed content proxies. So if you are serving your content over HTTPS and you include, or your users will include HTTP images, then you will have mixed content warnings in your browser. And this is not cool. So what is done? So this is that open source project by GitHub and by Fastmail. And they are rewriting the links to images, for example, and you are going through these proxies to reach the target destination. So you can use them as a proxy and, of course, as a SSRF vector. And hosted code. This is really cool. Parse.com, which is a Facebook company, allows you to store your own JavaScript code on their servers and then execute it. So my first idea was to develop a Node.js port scanner and execute it on Facebook servers. And it worked well. And YQL, which is a big Yahoo application, allow to import your own JavaScript code via YQL open data tables, which is something specific, but it's just JavaScript code which is executed server-side. And of course, each time I can execute code server-side, usually I score something big. So if you have more vectors similar to this one, I'm interested for the information. So this is the kind of features we are looking for, and there's everything which is application-specific. But with mixed content proxies, third-party data sources, developer resources, and third-party authentication, you have this kind of stuff everywhere. So we already have a lot of attack surface to check. OK, so we have some vectors. So we have some input fields where we can enter a URL. The question is, which kind of URL do you want to enter in this input field? So we have the left part of the URL, which is the URL handler, and then the right part, which is the domain name or the IP address. So, of course, if the file URL handler is available, you should use it and steal some password files or configuration files. This is easy. In some very specific scenario, you can reach file from HTTP, so you redirect via HTTP to your own server, you redirect to file, and then you can access files which are on the backend server. And if your target is using Java, you can use both proc and ... to reach directly in one shot, in blind mode, the configuration directory. So if it's using, for example, Ruby on Rails, you have some specific naming of the configuration files, so you can retrieve your content without any specific information on your target. And we have tons of exotic handlers, dict, PHP, jar, TFTP, and what else. This is not covered in this talk. If you are interested, you should have a look to the SSRF Bible made by some Russian friends. It's very, very cool. But I will focus on HTTP and HTTPS because they are always available. And so, in fact, I was using Gopher and whatever exotic URL handler, and they start to be blacklisted. Gopher is not available in recent version of Java, so I had to switch to HTTP. So I did it, and it worked well. So when we use, for example, the HTTP URL handler, we have a lot of possible targets, destinations. We have, of course, everything which is HTTP and HTTPS applications by design. We also have every services that we can interact through HTTP. So, for example, a Redis database can has a very forgiving text-oriented interface. So you can, for example, go through a proxy, a Squid proxy, and hit a Redis database and still send command and receive the output of your command. So you can really interact nearly perfectly well with the Redis database. And you have everything which is only fingerprintable, like SSH and SMTP. So two small points on SSH. First, if you access a SSH server through Squid, Squid will consider that your SSH server is a valid HTTP 0.9 web server. And if you look at the spec of HTTP 0.9, it is. So you can reach SSH through Squid. Of course, you will not be able to log in or brute force password, but you can see the banner. And this is very interesting because you can suppose that in a corporation, every SSH server will listen on the same port, which could not be the default one. So you identify that SSH is on port 2244, and you can scan the whole internet network for 2244 and identify any machine which is running SSH and probably any Unix server of your target. So it's really useful for fingerprinting your target network. Okay, the left part, the right part of the URL, which is destinations. We have two main goals, which are the loopback interface, because it's always here and it's very convenient, and the multicast addresses, because in some specific scenario you have some quick wins waiting for you. And if we can't compromise our target, then we have secondary goals, which are the internal network. So it's not by default my target of choice, and the public IP space. And we can still interesting stuff on the public IP space. And this is not port scanning random server, something better. Okay, so first loopback. So loopback is a network interface which is available in any operating system, in any version, everywhere. So you always have a loopback interface, and it always has the same IP address, which is 127.0.0.1. So you can already reach the loopback interface. It often hosts sensitive services, and by default, any IP-based ACL is bypassed. For example, if you are using a .NET web application, you can reach through loopback trace.axd, and you can access the debug information of your .NET application, including CCV, maybe. Or on Ruby on Rails, you can access the web console, which is limited to loopback, and you have this kind of behavior. Apache, you can reach server status only from the loopback. So it's very interesting to be on loopback. And then you have a lot of, for example, monitoring services. Yahoo has a custom Wymon web service that I compromised a few times. And you have some open source solutions. Console, which is orchestration software for cloud and large data centers. Monit, which is a monitoring tool. And given that you are on the backends, you have data repositories, everything from SQL databases, NoSQL databases, key value, key stores, Solr, whatever. You just have to port scan and you will find some stuff. Okay, this is very important. You are hitting the loopback interface. So most of the time, you believe that you are on the loopback interface of the backend server. But depending on the network architecture, your loopback interface may not be the backend, but a proxy, another server totally separated from your backend. And if you have an outbound proxy, then we have some interesting questions, like, is this outbound proxy shared? If yes, with who? Is it managed by your target, or is it managed by somebody else? Is it in scope for the bug bounty? So this is very important. Loopback could not be in scope of your bounty. This was the case for Coinbase, so it's an online wallet for Bitcoin, and I compromised their outbound proxy, and in fact it was Proximo infrastructure, which is a paid shared outbound proxy. So I compromised somebody else, and everything went fine. That was cool. But it was really a surprise for me to hit the loopback interface and compromise another target than my real, another company that my real target. The loopback idiosyncrasy. The symptoms are that you are scanning, you have one large application, you have several SSRF vectors, and you are scanning, for example, loopback, using all these features. And you have different results. So via one feature, port 22 is open, and via another one, it's not. Most of the time, it's because you have partial proxying, so only part of the features are going through proxies, and the other one are going to the internet in a direct way. So it's very important to notice this kind of differences. Or you may have a specialized backend. So depending on your target features, you may be routed to farm A or farm B, depending on what you ask for. Because you have to realize that most of the time we are in blind mode. So we really have to deduce things of small piece of information. Multicast, so that was loopback, now multicast. So if your server is a EC2 or OpenStack VM, and this is more and more prevalent, then your VM has a metadata server listening on this specific multicast IP address. So the same IP address is used by EC2 and OpenStack. So this is cool for us. So we don't need to identify first which technology is in use. If we can, it's a metadata server, we have a few interesting targets. We have some static technical information, which is always available and which is read-only, but you can learn about the host name of your target, the public or private IPv4 addresses, the MAC address, and whatever. So this is useful for understanding the context you are in, but you can't really compromise something with only this kind of information. It's only additional steps are needed. Oh, this is cool. If the VM is in auto-scaling mode, so if the VM can be created from scratch automatically and booted and started and everything, then you have a user data script. And this user data script will include most of the time private keys, passwords, links to source code repositories with credentials, and there's everything needed for booting the machine from zero to it works. So everything you need is here. And depending on the context, you may have AWS credentials waiting for you somewhere in a hidden directory. It's not hidden, but it's not on the root path, and you can access the credentials, and then maybe you can create your own VM and include them in the cloud presence of your target. So you're including your own servers in their data center. This is cool. I have attacked the other way, where I have remote data centers connecting me. It's cool too. Okay, so this is multicast, and this is very interesting. Mostly the two last points, and the first one is only for the sake of having more information on your targets. Sorry, I'm drinking a lot. So, if we didn't manage to compromise using loopback or multicast, what is the time? No? Oh yeah. Give me 20 to 30 minutes. So, internal network. So we were not able to score on loopback or multicast, so we still have the internal network. So most of the time you have internal network. In some cloud-only setups, for example, part of the Prezi infrastructure, you don't have internal network. It's only servers with public IP addresses listening on the internet and no private links or nothing. But most of the time you have an internal network. And on this internal network, you have tons of non-hardened services. I mean, you name it, monitoring, statistics, databases, key stores, web servers, administration interfaces like your Tomcat, port 8080. This is usually very cool. But you need the addressing plan. I mean, you need to know the network range in use, and if your company is using something like the 10.0.0/8 network, then you really need to find some information about your target, because you can't port scan this kind of network. Maybe your SSRF vector has some rate limitation, so you can do only 100 requests per day or per hour or per minute. So then you go to Google Groups and you look for all posts from a sysadmin, like I'm running on this IP address, and this is the kind of information nick you are looking for. Okay, and by the way, this is always the same problem. Maybe the internal network is not in scope. So this was GitHub. So GitHub has a product, mixed content proxy, which is Camo. Camo has a vulnerability, and I explored the vulnerability on the GitHub instance of Camo, and I was reaching the internal network and finding Tomcat servers and thinking that I will score a nice bounty. And then I sent an email to GitHub, and the answer was, okay, you are hitting an internal network, but it is not our internal network, because proxy is auto-seed to Cloudflare. So in fact, I was scanning the internal network of Cloudflare. So they have Tomcat servers. If somebody of Cloudflare is here, I can give you details. So keep that in mind. You may not be in scope. So if everything else fails, or they have some very good blacklist, then you have a small window of opportunity still. So let's suppose that the ACL applied to public traffic are different from ACL for internal traffic. This is pretty common. And if you have this first condition and then some private services listening on public IP addresses, then maybe, given that you are inside, the internal ACL will be applied to your traffic, and maybe you will be able to access some resources on public IP addresses which are not reachable from the outside. For example, so I found a proxy on parse.com, and knock.parse.com, which is of course the network operation center, as a public IP, and it was hosting a Go debugger, a networked Go debugger. So I can just connect through the squid proxy and interact with the Go program being debugging. So that happens. And it's quite hard to defend, because you need to know all the IP addresses used by your company. And it's sometimes a small mistake is enough for me at least. Okay, so we have vectors which are features that we will abuse. We have targets which are destinations. So loopback, multicast, and maybe the internal network, and maybe some public IP space. And between us and the bounty, we have blacklists. So we will bypass them. So we only have a few destinations to forbid. So implementing blacklist should be easy. For example, maybe we want only to restrict loopback and multicast. So there's 2 IP addresses we want to block. So is it easy? No. And we will take these 2 targets as an example. So we will start with very basic stuff. This is very basic. So nicob.net is my own domain, personal domain, and this will resolve to the multicast IP address. So if you don't resolve a DNS name before applying your blacklist, which is very, very, very dumb, that will be enough, but in real life that do not work. If you don't have your own domain name, then you could use xip.io, which is a free DNS service, so you can register. I mean, it's on the fly resolved by the server, so you just need to put your IP address .xip.io. If you want to be a little bit more discreet, you can encode your IP address, so this is the same one that here. And here you have the formula to apply. So welcome base 36. It's a newcomer. Of course, you can prepend. So you can have www.owasp.org. Blah, 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 blah. And if that's useful, if you have a whitelist waiting for w.owasp.org on the left side of the URL. So DNS, it's ready for starting. HTTP redirects. So we want to redirect with HTTP status code 302 to the metadata server. And we have, of course, a static way. So you hit this URL and you are redirected to the metadata server. And you have a dynamic way. So this is free for use, so everybody could use this kind of stuff, but do not forget that you are leaking some information to me. So this is, we will be redirected to HTTP, this IP address, this port, and this path. So you can, with one simple URL of this format, you can redirect to everywhere. This is the dynamic redirect. It's useful later for more complex stuff. HTTP redirects really work in real life. So for example, I was able to bypass the blacklist from Yahoo and Stripe simply by using redirect. So it's very, very easy to do. And there's much more than status code 302. So 302 is the most common one with 301. But if your target server is sending a post request and you still want to have a post request after redirect, then you need to use status code 307, and depending on the client, you may have post before the redirect and after the redirect. But this is really client dependent. And by client, I do not mean browser, I mean server-side stuff. Okay, you may want to try some loops or multi-steps loops. So one URL going to URL 1, going to URL 2, going to URL 1, and again. And then you may have some error messages, and maybe you will be able to fingerprint the underlying library, and then you have some specific tricks to apply for this library. And this is not related to blacklist. Sometimes the website or the API are very cumbersome to deal with. So what I do, I register one single URL which point to my own endpoint, and then on my own endpoint I modify the destination dynamically. I did some cool stuff on GitHub, so no, it's too long to explain anyway, tonight maybe. So I don't have to interact anymore with the target. I just register one IP address, and then using, for example, the user agent or one other header, I instruct my redirect endpoint to redirect to IP A or IP B or port C or whatever. Okay. Alternate IP encoding. So this is some very old stuff that I was using 15 years ago, but it's new again, so that's cool. So the most common representation of an IP address is what is called dot decimal. That's what we use daily for representing IP addresses. So 127.0.0.1 is the dotted decimal representation of the loopback interface. That's fine. But every client, HTTP client, supports a lot more. So your browser, your proxy, your server-side library supports tons of IP encoding you probably don't know. And this web page was updated for the last time in 2002. And this is what I use for learning about this kind of tricks. So I used this page 15 years ago, and I use it like last month. So it's an oldie but a goodie, it's still working. On the left side, I will show some IP encoding, and on the right side, I have the name of the encoding. And if you want Udo to serve you some drinks, you need to shout the name of the IP encoding. Okay for helping? Yeah, or just ask, it works too. So, let me be clear. That's the IP address I will encode, okay? The multicast one. So, what is this encoding? No. Too late. This is dotted decimal with overflow. So, thank you. It's only the beginning. So what we do, we add 256 to the power of 4. No, excuse me. 256 to each digit. And of course, your computer don't mind. It will overflow. It will skip the left part, and it will resolve to the correct destination.
This works on all clients?
Everywhere. Absolutely everywhere. I mean, if you find something somewhere where it don't work, please tell me. I will take note of it, but it works everywhere. So this one. Yes, D-word. Okay, I call it dotless decimal because the dotless thing is useful for more than only decimal. Okay, so this is the D-word format, also known as dotless. This one. Yes, dotless decimal with overflow. So yes, you just need to ask to add 256 to the power of 4, and you have your new IP address. And this one, easy. X. Yes, dotted X. So of course we have dotless X. So as you can see, depending on your target, you may have only one number in your IP address. Okay? One number, then X, and then only letters. So your blacklist will have some hard time identifying its IP address. Okay, sorry for my accent and everything. Yeah. That's why I have slides. This one. Yes, dotless hexadecimal with overflow. This one? Oh, yes, octal. Octal is pretty cool because it really looks like, not octal, like an integer or something, but everything is prefixed by 0. And if you look to the Microsoft knowledge base, like MSDN or something, you will notice some tickets like people prefixing their IP address with a 0 and having very surprising results because their IP is converted to octal and then it don't work how they expect. And of course we have this one. It's easy. It's dotted octal with padding. So we just add some 0 on the left. Okay. So it's already cool. I have a script generating of all the mutations for any dotted decimal representation of an IP. So it will be shared soon. Okay. Of course, that's not enough. We can do more. We can do more. We can mix the encodings. Yes. So this is, of course, decimal with overflow, and decimal, and hexadecimal, and octal. Yes, I'm right. Fine. Or you can convert only part of the address. So the dotless things can be applied to only part of the address. So this is octal, this is hexadecimal, and this is dotless decimal, but only 2 byte wide, because you can. So, and you can try it on your computer right now. Ping this IP address, it will work. It's only for humans that it will be hard, but your computers already managed to this kind of format, no problem. Okay, so that's enough for IP encoding. Oh, no, that's not all my content, but it's a little bit later. IPv6. Most of the time, your target operating system has IPv6 enabled. Maybe it's not used, but we have IPv6 interface. So you have some specific format, so square bracket for this is the IPv6 address, and you can just prefix with 2 colon, and this is what is called IPv4 compatible IPv6 address. Or you can put 2 colons and then 4F and 1 other colon, and this is IPv4 mapped address. It's not very common, but I mean, why not trying? If it works one time per year, it's enough. Okay. So the previous example were for the multicast IP address, okay? And that's all my tricks, or nearly all my tricks for generic IP addresses. But loopback is very specific. So loopback has its own bag of tricks. So yes, loopback is a /8 network. So you can use 1, 2, 7, 4 times, and it's still loopback. This is easy. But I already made some blacklist where loopback is a /24. So it's easy. Yes, this one is awesome. 0000 is your loopback interface, and nobody include by default this IP in their blacklist. So quite often this is the only bypass I have because everything else is blocked. And oh yes, by the way, you can reach only services binding any interface. If you are bind to a specific interface, you will not be able to reach the service using this IP. Anyway, that's still cool. And you have some IPv6 representation of loopback. So this is a representation of the classic 127.0.0.1 IP, and this is the IPv6 representation of this one, 0000. Okay, so it works. So this one, you have the same constraint. So you will be able to reach only ports which bind any interface and running on IPv6. But SSH, for example, can be reached that way. Okay. DNS time of use versus time of check. So this is a race condition. Step 1, your backend server will resolve, apply a blacklist. Of course, the IP address is legitimate, so you are allowed to go to the outbound proxy, and the outbound proxy will resolve the destination, and you will reply with a private IP. And of course, given that the blacklist was before on another server, you will access the private IP address. And technically, it's quite easy to do. You simply need a dedicated DNS subdomain. And DNS Chef is a cool software to use. You will have to patch a few things, but it's a good starting point. So that works well. Christoph, you tried this bug on Prezi, no? After my talk in Geneva.
If I did, I was very drunk.
At least you had the idea of testing this stuff. Okay, because Prezi told me, oh, just after your talk in Switzerland, somebody scored with DNS rebinding. Okay, so Okay, somebody else. So.
I have another one. We're trying some of these tricks on a system, on a transportation system.
Mm-hmm.
It didn't work. Nothing worked. And the last try was actually a typo, and everything that didn't resolved to loopback.
Oh, cool. Oh, I need to try this one. Usually I do enough typo for detecting this kind of stuff, but thanks for the trick. If you have more tricks, feel free to give them away. Okay, we have features to abuse, we have destinations we want to reach, we have bypassed the blacklist, and now we will compromise, do some pawnage. So Stripe. Stripe is doing some payment, processing money. If you look to the JavaScript code of their checkout features, you will find a function which is never called from anywhere. And it takes only one parameter, and the name of the parameter is image_URL. So for me, it sounds very cool. And this is what you can find in the JavaScript code. So you don't have a lot of information. You have the name of the parameter, and it's a get, and you will get a JSON data back, and this is your target. And in fact, yes, we add a client-side blacklist or client-side blacklist. I don't see the point. Anyway, they also have a server-side blacklist. And everything is blocked, loopback, internal, multicast, but before following HTTP redirect. So you only have to redirect to your own server and then go back to the internal network. And this is what is possible. So I call color, this is the parameter, this is my dynamic HTTP redirect endpoint. I'm hitting port 30,000, and this is their own non-standard port for SSH. So no, I can port scan everything for this port, and I will be able to fingerprint the internal network. At that time, this bug is quite old, so I was reporting before exploiting at that time. So I got only $500. Did you go to the talk this morning by BugCrowd? Okay. Most of the time I will be much higher than the payout discussed this morning, because you really need to find new bugs and exploit them to have the maximum rewards. So this one, 500. Oh, pretty. Pretty. They are giving away t-shirts, so, and they are cool. When you save your presentation, you are sending a post request with a very large, so you can see the size here, a very large blob of data, and the parameter name is b64_zip_xml_content. So I was thinking, oh, maybe not, but maybe it's some XML documents and zipped and encoded at base 64. Let's try. I tried, and I wrote an extension for burpsuit, applying this kind of decoding and re-encoding, of course, and then I can manipulate the XML document manually from burp, so it's easier. And I was thinking XML. So XML. I'm now for some XML stuff. So I tried a lot of attacks. I didn't find anything working, and I was really disappointed. So I tried to insert a small image to my presentation. I remember it was a little yellow star. And then you have a new node, object node. Sorry. Here you have an object node, and you have a lot of stuff. And here you have a URL node, and you have the public URL of your image. When you imported the content, it's fetched from the internet. Okay, the fact is that now I can save a Prezi, including some URL pointing to my own server. But I need to ask the proxy servers to retrieve this content. So if you export to zip, portable format, I already said that, so okay. Exploit with a S because I had some bypasses. So the first one was file etc password. This is very easy, and no HTTP redirect because the library will not honor redirect from HTTP to file, but just entering file is enough. So 2K for this one. Then they blocked the file URL handler. I went to the metadata server and 2K. And then they introduced a lot of defense in def mechanism, and I was able to bypass their blacklist using octal encoding. Okay, so let me explain. Their blacklist is using IPY, which is a Python library, which is not patched. So I reported this bypass to them. They didn't patch. So if you are using it, beware. And I got only 500 because this bug can't impact them. Even if I can bypass the blacklist, they have so much defense in def mechanism that I wasn't able to do anything with it. So it's 500, but just for the IPY bypass. PayPal. So never do the bug bounty of PayPal. It's the worst one. What to say? So they are managing money, a lot of money. You have interface for testing IPN request, and they have a blacklist, of course, that's PayPal. But the blacklist can be bypassed with octal encoding. And so as a proof of concept, I send the IPN to this internal IP address, and I got this feedback from the web application. IPN successfully sent to the decoded IP address. And surprisingly, I did not exploit the bug because I was quite busy at that time, and I got only $100. So I can reach the internal network of PayPal, and they gave me $100. Okay, bye-bye. This is a private bounty. So John Doe, number 1. So callbacks again, and no restriction, absolutely no restriction. It's wide open. So I port scan the internal, the loopback interface, find this port, which is the default port of console, and then I can discuss with the agent and retrieve some information. And they fix the bug, and then I use 0000 to bypass the bug. And I found, okay, this is their SSH port. So if you want to, but you don't know who it is. So. Anyway, and $750. Coinbase. So this is the most, what to say, the minimum amount of time for the maximum amount of money. It's half an hour. So Coinbase, it's an online wallet for Bitcoins. You have a callback interface and you have no restriction. So I compromise their outbound proxy, and I got all the credentials for EC2 and Heroku and the source code repository and everything. And in fact, it was Proximo. So Proximo was really cool. I mean, they could sue me. They were really cool, and the bug was fixed. Yes, the bug was fixed, and I was paid in less than 24 hours. So Coinbase, they are third-party providers that they need to inform of the context and everything was done in less than 24 hours. So congratulations to them. And 5K. So half an hour for the bug, half an hour for the reporting, and 5K. That's nice. Another private program. Oh, Mario, I will be late. Okay, thanks. That's cool to give a talk at Actra. Mixed content proxy, so another private program. If you add links to external HTTP images in your blog post or in your I can't say exactly as a vector because you won't know who it is. Okay, anyway, this is a perfect SSRF vector. You can use any HTTP method. You can send any HTTP header up to the final target, and you get the full responses, even if it's a HTTP error or whatever. It's totally transparent. So I scan for port 8400, which is console, and given I can use any HTTP method, then I use put to create a new check. So here I register a new check in console, and of course the check was executing a bash shell. And here it's a GET request, and I retrieve the output of my shell just to see the etc shadow password. But in real life, you may only need this one and send your connect back shell. I mean, you don't need the output of your command, but in order to explain and to be understood by the target, I really want to show the output, and this is your host name, this is your own password, this kind of stuff. So what you need to remember is if you have something on port 8500 and you can do a put request, then you have a remote root shell. So 3K for this one. In fact, I think that their maximum is 1K, and they gave me 1K, and 3 days later I got an email like, oh, we had some internal discussion, so that's not what you expect. And we decided to give you 2 additional K. So, thank you. Discuss more, no problem. Yahoo! So, the Yahoo saga, because it's very, very long. I will try to be shorter. They have an existing blacklist on both the IP address and the TCP port. It's before redirects. So, I use my dynamic endpoint, so this is another one, but old one, and I was able to find this kind of output. So this is not found, this is method not allowed. I mean, I can't reach your loopback interface and interact with it. So I sent a bug report, and it was closed as won't fix because it is working as designed. Okay, please call me the designer. So, of course, the reward was 0 because it's not a bug. I mean, right now, they didn't consider it's a bug. So, let's go back here. Here, it's port 9466 and method not allowed. So, method not allowed, we switch to post. We have an error message, which is a SOAP error message. And in this SOAP error message, we have the Wymon namespace, which is not a public namespace. So, I Googled for Wymon and WSDL, and I found one single question from 10 years ago. And I had this feeling. Maybe you are reading XK CD, and this is this feeling. You are looking for something, and only 1 people worldwide had the same problem than you. So I click on the link, but without any expectations. And then you discover this awesome page. I'm new in SOAP. Okay, me too. Blah, 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 blah. And here, target namespace, HTTP internal Yahoo server running on port 9466, and this is wymon.wsdl. This is exactly what I was looking for. So I have 1 hit in Google, and this is like, woohoo! It's perfect. So yes, big win. What else? Next step, of course, is to analyze WSDL. So nearly 500 lines, 11 methods. And when I looked at the name of the method, I was like jumping around. Exec, echo, ping, version, yoo-hoo! And okay, exec. This was my first try. So interesting. But in fact, you can exec only files stored in a specific directory, and in this directory you only have Negios plugins. So, okay, time to audit some Nagios plugins. It's in Bash script, so it's easy. And then I discovered that checklog is very friendly. So I asked for everything in etc and please sending to my own IP. So this is data exfiltration. Then maybe you could copy Bash to checknt, which is an existing plugin, because if I create a new file, I don't have the executable bit set. So I need to overwrite something, which is done. And then I just need to call checknt and you name whatever you want. So this one was cool. This is the output. So as you can see, I'm inside a proxy form inside Yahoo. Okay. Yeah, 15K. That's not the best one. It's the second best one. Okay, and then part 3, because it's very long. So I found a bypass, and using X encoding, I bypass both the IP and port check. I have no idea how it's possible. Probably an exception was raised or something. And so I did it again, but the web service is now running as user Y and not root anymore. So I want a root shell. In fact, by reading configuration files, I found some master servers, and they were not patched, so they are still running as root. So instead of compromising one proxy, I compromised all the master servers. And then I bypass the fix again. And yes, this is the third bypass, and I have 2 new ones which are not fixed. And the bypass was paid a little bit more than 6K because Yahoo, by policy, pay less for bypass than initial vectors. I'm not really, I'm okay with that, but I consider that as long as you have a root shell, whatever the vector, you still have a root shell. So if it's a bypass, it's their fault. I'm not writing the fix. So. Okay, this is the last one. Parse.com, which is a Facebook company. So you can use, you can host your JavaScript code. We will use parse hosting because you don't need authenticated calls. You can just call it with your browser. And you are going through a form of outbound proxy when you do external requests. Okay, private and multicast IP addresses are filtered, but no loopback. And of course, it's Facebook, so it's so huge that you will find internal services running on IP addresses, on public IP addresses. So for the first one, so I wrote my Node.js port scanner, then I wrote a proxying, application layer proxying application, so I can browse. I will give you a screenshot just after. And for the second trick, I was able to access a Redis database. And as said in the beginning, you can fully interact with the database. So I was able to reconfigure the log file to var.w shell.php and stuff like that. And of course, you can't reach this database from the outside. You need to be inside. So screenshots. So this is my application, hunting.parseapp.com/browsers URL equal. And it's still working. So of course, this IP will not work, but you can browse whatever site using this application. So it's quite easy. You can click on links and you can visit the internet network of Facebook using your browser. So it's comfortable. Yes, this is my application, which is dedicated to Redis. So this is my target. This is a blob of Redis command base64 encoded. And of course, you can see here HTTP headers, which are refused by Redis, of course, and then my content and the feedback from the server. Okay, plenty of stuff on public IP addresses and a Go debugger for user bin shovel. So this is funny, thanks Facebook. But no way to get remote code execution. So I was thinking, should I spend more time for remote code execution and maybe have a duplicate, or should I report and rely on the Facebook security team, which is known to be awesome? So yes, I send them a report without RCE, and they send me 20K back. So it appears they understand the impact of the bug, which is cool. And that's all for real-life bugs. I have much more, but I'm already too long. Toolbox. So what you need a script for mutation of IP addresses, which is alternate IP encoding. You need endpoint for HTTP redirect. You don't really need a valid SSL certificate. Most of the time, they are not verified. Web beans are really useful. So it's some servers which are stocking your last request or your last several requests. So, I mean, just check. It's useful. You need a dictionary of common ports on the loopback interface or internal services like databases, SSH, console, whatever. If you are using Burp Suite, you can use the global search feature. For example, you can look for equal HTTP or URL equal. It's very basic. You will miss everything which is REST or XML parameters. Of course, you need a dedicated DNS subdomain. It's useful for detection, so that's used in Burp Suite now in the collaborator tool. So I use it manually too, and I use it for blacklist evasion, so DNS rebinding. A patch copy of DNS Chef, and this is my own copy. So this is for bypassing blacklist. I give a scheme, which is 212. So it will answer the first request with the legitimate IPs and the internal ones and the legitimate IP. So the use case is this is your backend server resolving the name, this is your proxy server resolving the name, and this is your logging server resolving the name. So everybody will believe it's a public IP but the proxy, and you are interested in the proxy, so that's perfect. So first request green, second request blue, third request green, and then we switch back to another, also back to number 1 because it's a new loop. HTTP redirect, very easy to use with Burp intruder. So you just need a htaccess file. So this is your source, URL handler, IP, port, and path, and this is your destination. So in one line of htaccess, you can have your dynamic HTTP redirect endpoint. And that's all. Oh, maybe I have a conclusion, so quick. Attackers, if you really think about it, welcome in the world of web machines. I mean, like everything in InfoSec, as soon as you are deep inside it, you will see the web machines. You will think about primitives, you will think about export chains, and if you want to discuss this kind of stuff tonight, you are more than welcome. And defenders, if you really need to access only public resource, put your outbound proxy outside. On EC2, on Cloudflare, I don't care, but do not take any risk if it's not necessary. And outside of that, good luck. And I'm late, but that's all, and thank you for listening. I'm not sure if I have time for questions, probably not. No. So I'm free, I'm available for questions now and later, tonight, tomorrow.